Hello, and welcome to another video. Um, so this one I am going to, it's been a while, but yeah, I thought I would get back into it. I've been doing little hobbies on the side, but I thought I would do some networking or something. Could be fun. So I pulled up this RFC here, so RFC 867, it's quite old, it's from the 80s. And this is kind of implementing just a little protocol that basically all it does is print out basically the same as what date does, but over TCP and UDP. So I thought this could be quite cool to kind of look at implementing. And as it says, a useful debugging and measurement tool. So what I want to do is actually try out a few different ways of implementing this, and try and see, well, basically just try and drain all the power out I can possibly. So I don't know, maybe I might get millions of people hitting this all at the same time and getting a decent return code. So this is kind of cool. Basically, there's no specific syntax for what you print out, but it's just print ASCII characters, and only do it in one line. So, like, this is one way to do it. This is another way to do it. There's a few different ways to print the date, but we won't focus too much on that, and I'll just settle on one way and we can kind of change it about if need be. So what I guess we could do is make a, well, maybe we'll even make a RFC 867. We might just do 867 daytime. And we can start making something here. So what I might do is start off by making a client. Cool. So we'll probably have something like this. I've been trying this kind of syntax, which is, I think it's like the K and RC, but Vim kind of has some useful hotkeys. So like if I'm like, say, in the middle of a function and I'm like, how do I get back to that's not a good one. I need to, yeah, that's the key I want. So I might have something like have another one up here. And so like I might be in here and I want to go. I can like kind of go by lines, but that's no fun. But I can also go by kind of functions. So I'm kind of jumping to the top one of these every time I do that. And you can probably even go to help for that. And I might even bump up the little text for this. But yeah, it basically searches backwards to the previous curly brace in the first column. It's kind of funny. I had a funny chat about parentheses when I was getting my hair cut the other day. I got my hair cut, which was kind of why I was wearing a beanie. Well, various reasons. I want to keep warm. There's reasons why. But yeah, she is American, and I am not actually American, or from the United States of America, or whatever people want to call themselves. I'm actually from New Zealand, where we have like a weird hybrid of English that like half came from Britain and half came from USA, and did like a weird hybrid mingle. And we were talking about what people might call these, and she was like, oh yeah, people call them brackets here. And I'm like, oh, well, they're kind of brackets, but they're also parentheses, because like in computers you kind of call these parentheses, but you can also call them brackets. And like, then what do you call this? And I was like, oh, some people call it a brace, but like all sorts of things. And then what do you call this? And like, oh, that's a square bracket, or a square brace, or like, oh. It was kind of funny. hairdressers, you have interesting chats with hairdressers if you kind of chat with them a little. So anyway, what do I want to do in this? After kind of rambling in here, I probably want to accept some, what do you call it, arguments. Nothing too fancy, so perhaps if we not equal to, so we have one for the command, then do that, and I still kind of keep that brace style, but I don't know if I want to, because even if I had one, if I change that to that, even if I do that, it will still go to the top one, because it mentioned in the first column, which that is the first column. Anyway, enough like them, like stuff. I haven't done a video in a while. I like just, I don't know, doing some things. So if this happens, we probably want to have like a usage. Well, like, yeah, sure, why not? So we can probably just pass in, well, I kind of want to maybe just make this a define usage and like maybe exit. And this function, all it really does is we can do like a do while kind of construct. What do I want to do in this? I want to kind of just go, what do I want to do? I want to print, if we want to print a standard error, and we probably want to print a usage message, and we want to give a command, and what do we actually want to accept in this? So I think what I want to do is get a host and a port, and perhaps that's it. Perhaps I could do like some fancy stuff like the host and port all in one, and I just detect a colon in that. We'll start with just host and port. It's kind of easier to do. And what do we want to do here? We want to do this. It's kind of interesting starting again with this, because I've kind of done this project a few times now. So here I think I just want to go return 1, but we'll have to kind of do a few, I kind of want to, from here I want to just do that, include, I'm trying to, after all that talking about brackets, that brackets on the other hand, with my fancy keyboards, I've got a Moonlander keyboard. So what do we need here? We need standard bool, and we also need standard I/O for printing stuff, and then we can just go here. So this is almost right. That looks about better. So here we can kind of just go usage exit, and just makes that code a little nicer, because now we can go just host name equals the, so there'll be 1, and we'll also have a port string, and there'll be that, and that kind of means that we need to check for 3, so we're on the money there. I kind of also want to check whether these hostname and port is legit, I guess, and how do I do that? So, I guess to start with, I kind of want to see how I'm gonna like connect to a server. So there actually happens to be a syscall for connect. And what do? We need a socket and a socket file descriptor. So this we need to kind of get from the socket command, and we can go through that in a second. And what else do I need to do? I also need this adder. And does this talk about what the adder is? The format of the adder is determined by whatever socket it is. So I'm not sure why I ended up all the way up there. I was here before. So we probably want to have a look at socket. So what do we want to make in this? I kind of want to make I see there's IPv4, and there's another man page for this. I've already gone through this man page nonsense, but you can also do IPv6, which is, you have to do it differently. So when we do this, and we also want to have either a stream, which would give us the TCP based, or a dgram, which is a datagram, which we can use for the UDP based stuff. I'll stick with the stream stuff first, because reading this is kind of there's an attack, a security attack, like amplification attack, and this is like perfect for it. You basically connect to a service, and it responds to the address that you have in the UDP packet, and then that could be anywhere, and it will send a message that is, I don't know, this long. It's not that long, but imagine spamming a server millions of times with not your source IP in the UDP packet, which is like possible to do. So we'll just stick with the TCP for now. So that would be the stream thing. So we can look at IP. We need to have it in the 7th manual thing. That's what you need to do. You kind of need to include like a bunch of stuff. But yeah, then we can, so let's see if we can do the UDP target. We can do the TCP socket, so we want to do TCP. If you want to do like different protocols than TCP or UDP, you can do the raw pocket with whatever protocol you want. If you need to do that sort of thing, which some protocols definitely do. So, what do we need to do here? Yeah, so this is what we need. We need a family, which is that. We need a port, which is a port in network byte order. So we need to be able to get the address and then the port number. And we also need the address in network byte order. So, cool. We can get this. So, an adder can be used using this H2NL with the loopback address. This is only useful if we're binding it, I guess. But what we're doing is we've got a string and we want to kind of make something. So that might be one of these functions: inet to an, or inet adder, or inet make adder, or get host by name. The get host by name would only really be useful if you're giving a host name, not an IP address. So if we kind of inet a to n, what was it? I hate how it's like defaults to that manual when you're in there. 7, I was off by 1. I'll give it that. So what family? Inet a to n, inet adder, and make adder. So inet a to n, inet make adder, and inet adder. So these three things might be able to help me. So this is kind of, this actually points to all three man pages. So we got iNet A to N, iNet editor, and iNet network. So here we can pass in a thing, and we're passing in strings for all of them. What do they all do? So this is basically, if you have a string that is a IP address, then this will be able to do it. Cool. This also does the same, but basically different return codes in storage. Yeah, I thought that might be the case. And there's also P to N, which, what would that be? And there's also get editor info. There's a lot of things that you can do. Networks are fun. I could just copy paste some existing code, but does this have like some examples on right? So dotted address and iNet A to N, but there was also iNet P to N. So what about this man page? So here we cool. So this we can do IPv6 or IPv4. So that could be a thing that we do. And I think, yeah, do we only need to care about... Yeah, I think this is potentially a nicer way to do it. If we... like, do we detect that it looks like that? Because I assume that this, yeah, it's a library, is not as expensive as like shelling out to, well, not shelling, but we can also, for an interface that handles both IPv6 and IPv4, so get editor info will like just do both of those in the same thing. Is that what we're seeing? We need a node and a service and hints and whatnot. Alright. Do you have some examples? Get editor info. So we're kind of post port message. Cool. I think this is kind of roughly what I want. And then we had to like loop over this thing. And it's got like a... Yes. Get host by name. That also looks interesting. Host by name. And is this... It's deprecated, alright, so what do you suggest instead? This is slightly frustrating that it so get name info, what do you have there? Well, anyhow, that was dedicated. This is potentially what we want, but then if it like doesn't look like an IP address, then this will probably fail, right? So what is some code I can kind of just copy paste? Sure. We potentially need a bit more. Something like that. Alright. And then do something like that. Sure. What about that can just be what it is. Alright, so now we have a bit more stuff, and we can do something like that. Cool. Like we already have and like what did that have? No, not a log file. How do we get out of that there and do that? Do something like this. Then like equals b. I don't get why that's. We haven't actually made a. We make a socket there. I gotcha. Alright. What else did this do? We needed a SFD. We could potentially start making this. And what else do I want? And get some debugging in there, and we can probably just do a client.c and or did I want that in there? Cool. Then we can start doing some making and whatnot. I think I want to bring that over there. Cool. So we need to include like a bunch of things. I mean, what do you suggest? Systype, syssocket, netdb. Alright. Include sys socket.h, and like it also had type. Types, will it? guess it netdb.h. Cool, and that's strings. Was it not strings? Ah, it's just string. Unisted. Cool. So this should connect to the thing, and then we can we can potentially even write something to it. Hello socket, and maybe we could sorry, I'm having a slow day. We can probably just do strlen of that, and picked up that, did it? Something like that. Cool. And so in this we can maybe I won't do it there, but I can do it here. So where did I put that? I put that in RFC, that thing. Right. So we can move those things into here, and do that same thing. Cool. So I think it will fail if no, it won't. Cool. Well, it does. That one thing. And we did get 0. Alright, so do I still have that server running? Yeah, so I do have a server running. And that's what the protocol would do. I've already got a server that I could find my right keyboard. I could theoretically do that. So I theoretically have this. So the client isn't actually going to write something. It is actually going to buff. We know it's not big, so I'll just do that. So this can be maybe just a while loop, and we can just break out of it if we need be. So I just want to check memory and whatnot. So we haven't really done much yet. So Cool. And we can also do that. Yeah. So while we want to do this, we kind of want to read a thing. So we want to read from what we call it. I'll probably change that in sliders of buff. And so if red equals -1, what do we want to do? I probably want to do the error read and break. I kind of want to like fail. So C is kind of good for some things. So in here we can have fail, and all it does is does something like red equals 1, and then we can clean up. We can have something like that, and here we can just go clean up, something like that. Though there's like a kind of nice way to do that, which is through a little macro, and we can probably do something like this. So what we want to do is we want to have some kind of cleanup, but we also want to be able to just say, I want to return this code. So what we can do is actually do that. So what we want to do is we basically set whatever the value of that we're trying to return into a value called red, and we kind of assume that that kind of exists. And here we can just do a go to fail, and I wonder and then here we can just do a while false there. And so here we can have something like if SFD not if SFD not equal to -1, -1. Oh golly. Then we want to close that, and that kind of means that we want to make sure it is starting as -1. If I get the right key. I think I want to call this adder info, and here we can say adder info and find the S and do that, and adder info, and then we don't need this S, and I kind of want to change this to be sock FD. It's just how I see things. Cool. So if we go back to here, this, yeah, I don't know, we can also do that. I kind of want to clean this up quite a bit. So hence we can actually do kind of all this in line, and it will magically do the thing. And I think if that is the case, then we want to do I probably should have done a, what do you call that? And I actually wanted this to be a stream thing. It's interesting that it's still connected. Well, I suppose the hints doesn't like determine it. And perhaps the first one was, yeah, because we created with the family there. I don't know. I think I don't actually need that, and like these will just stay as 0, so we can probably just have it as that. And is that too long of a line? I mean, not like overly. And like, what even is this value? I mean, it could be anything. But yeah, I'll leave it as that. Then we don't need that mem set, and then we don't need this, in fact. So if we do this, it still doesn't like something here. That is because we didn't have a semicolon. Perfect. And here we probably want to do that defer, return defer, yeah, and then we can return defer 1. And this wasn't going to be fail, it was going to be defer, and we're going to return a thing called ret, which doesn't exist yet, but here we can go int ret equals 0. So default we will, well, we can even go exit success. I believe that is a valid thing, and it maybe says a bit more what it is. So usage exit can potentially still do this. Well, like we can just do just in case, exit failure, do something like that, and that probably means that we and like perhaps I'll do that as well. Then we can just jump through the functions a little easier. Cool. So here we can probably go return defer exit failure. I kind of like that. And here I kind of want to put in that. So if we couldn't do that, we're just ignoring the error and we're just continuing to the next one. If we connect to something, and we'll just silently ignore the error if we don't. Perfect. Yeah, I feel like man, this was host name. Cool. So if we read, what we want to do is we, well, actually we first want to check if red is also equal to 0, and then we can just break. And this kind of one makes me think maybe I should do it in switch, but then the brake gets a little confusing because the brake breaks out of the switch as well. But I don't know, 2 if checks in a row isn't too bad. It starts getting to be you try and think of the hot path, because this is like, if I was doing this a million times in a row, this is just the climb, but if I was doing this a million times in a row, what are the slow bits? What would it not be working on? I don't know. And now we want to do like right, but we also want to do like something like that, and then while written not equal to red, we want to write out everything. So where do we want to write it out to? We actually want to write it out to standard out file no, I believe it is. And we want to write buff, but we actually want to offset it by written, because we may write 1 byte and then write will return, and that's why we've got a loop. So now we can offset that 1 byte, and that also means that we want to minus off the total of the buffer. Well, not even the total of the buffer, the total of the red amount of the buffer. So we want to do that. And here we can also have some errors. So if this is negative, then we can probably do that same p error bit for right. And we can probably return defer and with a failure. And right can return 0, but it doesn't signify anything. Whereas if we go up to read, a return value. So this is quite a wide screen. So return value on success 0 indicates end of file. So end of file is like end of file or end of socket really. So if we get there, we want to break out. Otherwise, we kind of want to write everything. I kind of want to split this up into well, that might not need anything, but do that. And here we can basically just say whatever we did write out to standard out, we can just say that we wrote it out. And then once we wrote everything in the buffer, then we can go back and then read some more buffer. So this is iteration 1, perhaps, of a socket of, I don't know, client. Did that still not go? Oh, where does exit success come from? Standard lib a. So include std lib.h. Perhaps I should write a thing to do that. So defer is defined but not used, but is it not? That is because we actually want to do defer there. Perfect. Cool. So now if we do this, it should print out everything that it got from the server. It's actually kind of handy. I've got a server that is running. So it prints out everything it gets, and then it returns. And we should close it at the end. Now, I actually wonder whether... yeah, so what I can do is set up another tool. That was in the talk hierarchy I wanted. That took a long time to do that though. That wasn't either. What I want to do is get a tool called Wireshark perhaps, and we can bring this open. I've got a bunch of things. So I want to get, make sure that it doesn't show up like a whole bunch of things. So we can go, I also want to do localhost and also TCP port is that what I do, and then do that. And then here, if we do that, it should bring up a bunch of things. So this is us making a connection. Cool. So how TCP works is it has to do like a little handshake to start with. So the handshake is you send a request with a SYN flag, which is, I don't know, means you want to start a connection. So you want to maybe for like synchronize, I want to synchronize. And then the server, it will respond. So the server happens to be the same IP, but if it comes from port 1313, this one, I wonder if this font can come up. I'm not too sure if this large main window text. Perfect. Golly, I can be like that. So we do a SYN, then we do a SYN ACK. I kind of want to see that as well. So the server sends a SYN ACK, and then we send an ACK, which an ACK is short for acknowledge. We acknowledge that we got that SYN ACK back, and at this point here, the stream has started, and you see here we also have like sequence numbers. So the sequence number will kind of go up, I believe, but you see here it kind of jumps a little. So we acknowledge that, so we've started it, and that is our sequence. So now the server is sending us stuff. So it is push, I believe the push is, and it's also acknowledging a thing. So here we said we were acknowledging one, which is basically we're acknowledging we're on the thing. And here the server is acknowledging the sequence one, I believe, or it could be just that one. I'd have to read the spec again, but anyhow, this push has the data. So down here we can see the data, and the data just looks like that, which this potentially, can we show it as, no, not that. How would we get this to show as, decode as, no, I won't wing this off the top of my head, but this is the ASCII for the date, likely that. And you can see here there's a space, and then 3 spaces later there's a space, there's a double space, and then the 3 2 is just the number 2. 3 1 is 1 in ASCII, and then here we got a 3 4 and a 3 9. So we should, there was a 4 and a 9. Yeah. Oh, there's some stuff off the screen. Yeah. Look at that. Yeah, and so that's what it says in pure ASCII. Look at that. Anyhow, so then we do that. Then the server kind of, we acknowledge to the server that we got that message. If we didn't send this, the server might send it another push again. But this is good. And then at that point, the server is sending us the server's sending us a fin ACK. Yes, so the server is sending us a message saying that they have finished sending stuff. They're not, they're not like closing it there, but we also close it. I don't know. We initiated the close, but the server, once it finishes sending stuff, it will initiate a shutdown and then a close. I don't know. I guess what I can do is start another one, and this one, it hasn't closed. So we can see here we start another synac ack. We get some more data, and that data should have the now date. And then here we do an ack, and then the server does a fin ack. So the server is saying it's not going to send anything more, but we haven't actually closed off the session. So what we needed, we acknowledge that they have sent that message, but until we close this, we as the client don't send this thin ack back to that, and at that point there the connection is closed. There's other ways to do it, like you can have unsafe ones, like just reset, which connection's gone, but anyhow, that's and then without things. So that is a little something into how our first client is going. So I kind of want to allow multiple connections to the same host, if that makes sense. I also kind of want to see what happens if I give like weird stuff. So that's a weird message that I probably want to make a bit better. And what happens here? Name or service not known. And if we go to like example.com and like 80, they won't actually send anything, so this will just hang. But cool, so we can do DNS lookups. That one, I think I'm happy with that. The port error, I kind of want to make it a little better. So what we can do is we can char start end, and I think I want to make this a little function. So we can maybe up here we can do. I might make it a bool, to be honest, and it is valid port. We can say we passing in a string. We can just call it maybe something like that. Cool. And so if in here we can do a char start end, and then we can do long. So I'm going to get a long. That's cool. And SDR 2D, is that the one I want? No. 2L, of course. SDR 2L will give me a long, which will fit in a certain thing. Now, long's fine, I believe, because really we just need something that is more than 16 bits. And if we open up a browser in 10 seconds, we can probably see long data size. Let's see. It's like different. I can't recall which ones are which, but int is like the same on everything, but a long should be a long sign capable of doing. So it's basically a 32-bit, at least 32-bit. Easy. That's all we need. So unsigned long, we it could also do. But what we want to do is get it in the unsigned int data type, which is nicely also uint 16 t, which is defined in is the int. We haven't included that yet, but we can in a sec. But so what we want to do this is we can do something like this in SDR2L, and we can port what do we want to do? We want to give a pointer to a string, and then a base. And so end, and I'm going to give a base of 0, which kind of means that you can have an address such as 0x 1313, which isn't the same as decimal 1313. It's the hexadecimal, which could be useful for some things. I don't know. So at this point, if end is not equal to a I think that's what we do. If this is that, then we can. Well, we can probably just go return. Something like that. Boom. We can. Yeah. So. So if not is valid port string. So at this point here, we can probably do if printf rescue error invalid port number. Now I do also wonder. At this point here, I kind of want to give a usage exit. Which one do I want? I also wonder whether, because there's a file, services, in which we could potentially see if xtel is what it is, and so in, for example, netcat, you can just go xtel. So I do wonder if I want to be able to support that. So serve name not supported. I think that's this one, EAI service. So and here, if it is EIA, was that what it was? Turn EAI, and I was looking for service. And EAI. Something like that, and service or no name. And if it is something else, otherwise we something like that, and and do that, and here we were. I think I'll take away the number as well, and this we can go host name. Cool. Can we don't actually care about it. Perfect. Yeah. No, I like that. Cool. So now what I want to do is in this potentially we could abstract out. Like I just want to connect me to a socket, if that kind of makes sense. But also perhaps keep that. So RP. I feel like RP is not safe to use after doing that thing. So I feel like this whole thing can be abstracted out into, because I kind of want to just do connect socket and give it a host name and a port string. I kind of want that functionality. Something like that, and then here we can go and connect socket and const char host name and const char port str. I wonder if I just call it just call it port str. Something like that. So in here, we do that, and here we can just return something like that, and here we can make a defer, and I mean, this is more of a fail. And if sockFD not equal to negative 1, we want to close sockFD. Um, and here we just want to return that -1, thanks. And here we can just go if you fail. I kind of wanted. Check that. Do we need hints after that? We don't really. So I think did we use that as a valid port? So validate who's port. It's not really even validating. We're going to get a thing. It's not really process either. What are we doing? We're going to be taking a host and a port, and we're going to be returning address info, which I guess we can say look up host port. That's going to be what we are. And here we can take that. But we also kind of want to have like a result type thing here, and here we can do something like this. So in this case, I feel it's different to that, I guess. So I wonder if, in this case, we would return -1, but here we would actually just return 0. And here we can return 1. So if it doesn't exist, it will be 0, and if there was an error, it was -1, and if we succeed, it will be 1. And so that will kind of have that, and like this kind of now needs to take in adder info, and we can just have it as adder. And like, do we want to do the freeing here? I feel like this, we don't really need to close the sock, I guess. So if that's just going to be our only error, and I feel like this needs to come out into this, but like perhaps if adder not equal to null, we can do something like that, and so that means that we need to have like a what was it? Adder info, and this is going to be called adder, and we can set it to null, and here we can pass an address to it because we want to save it, and here we wanted to do what was it? A switch on sock FD. Well, no, this isn't even. We first want to check if validity equals lookup host port. So here we want a host port, and here we want to pass in the adder, and here we actually just want to just pass in the adder, and perhaps here just to free up some resources, we can free it here. And do something like that. And so at this point here, we wanted to do a switch on a validity. And what I might do is, yes, again, things. I wanted to not do the usage exit there. No, stay in there. So if we have a -1, we probably just want to defer exit, return deferred exit failure, and we can probably just do that on that line. If it was 0, we want to do the usage exit, and if it was 1, that means it was successful. What I might do is do a break, and if it was a default, anything else, I probably want to have like some kind of unreachable statement. So what I can do is do printf std error, and perhaps I might do something like this, and unreachable invalid return code from lookup host port, and we can give the return code, and what do we want to pass in here? We want to pass in validity, and here I want to do a return defer exit failure, and perhaps if we do unreachables in other places, I might check up on that. Cool, so this should do that. Int sock fd equal -1. So those are the kind of things that we're tracking. Usage exit, and that means this, we need to do that. So here we probably want to check if sock fd equal -1, that kind of just means that we can't connect, right? So what happens, we actually print that message. I wonder if we print that message there, and especially because we don't actually have the host name and the port there. Oh yeah. And then we can do a return defer exit failure, and in that case this can probably just do something like that. Nice little easy function there. So we look up host, we do that. We don't really handle the errors here, but I think that is kind of what we want to do. And in here we, so we look up, we check whether it's valid, then we connect, and then we have this whole like reading section. So I think I kind of want to right, so here we need to do a struct header info RP is that. Cool. Let's something like that. Yeah, so I think I want to make this unreachable here, so just do it here, unreachable, and I kind of want to give it a format and other things, and in this thing we're gonna, and so here I kind of want to, come on, go here and then I kind of want to just have it as something like that. So this can kind of come back down here, and I think that's what I want, but I think I kind of like there's something like perhaps. Well, actually no. Well, we can put in these little macros to. It'll point to the lining code, not the lining code where the macro is defined. The lining code where you call the macro, which is kind of what I want. And then this, I potentially want to just do abort, which I think is sclib, which I have got. And that just did it, cool. What I might do is, if we do a thing without arguments, and like, maybe I'll just do that. Yeah, so now it doesn't like this, so, gosh, that takes a long time. So what I want is a C macro be a no. I don't know. Give me what it is. And just like see. Does just say it somewhere. That's just C++. It's also available in GNU C. And that one is just in GNU. That's really annoying that it pops up there. Cool, so I think that's what I wanted to do. Cool. We don't have some breaks, invalid. Cool. And like that just hopefully won't happen. Cool. So this is like, what can we do to improve this? So I actually have a server kind of running at the moment, as you can see, and it can handle like a fair amount of requests. So I wonder whether so like the thing is, yeah, what we'll do is we'll get a fourth thing, but this will be char star num string equals argv 3, and so that means this maybe not count. So this can be or argc not equal to 4. So really just those two are acceptable. So here I kind of want a count type thing. So we can default it to 1, and if argc equal to 4, then we can kind of make a number out of it. And so in here, I guess I don't have that stuff anything more, so we can just end equal to now, and we can probably just assign it straight to count actually. SDR to L. Well, I kind of want to along C equals that and count string, and we'll give it a pointer to that, and I'll let people get, well, like perhaps I should only let decimal, but I don't know, in fact it could be handy, but perhaps I should make use of the feature. So if end not equal to the null character, then this is something bad. So here we can go f1tf sv error invalid count, and we can give it the count str, and we can then give usage exit. Perfect. Otherwise, we should potentially, if c is less than 0, then we could also have like an error there. Negative count. Cool, and then we can just go count equals C because we've done all the checks and it is legit. And so here we can kind of start some magic. So here we only really need to do this once, but here we can do like a loop C, I equal to 0, I is less than count, and then we in this we can kind of just do all of that. And perhaps we can just print f, and we can do something like this and just prepend it with where we are in the thing, and then this should hopefully kind of send us the rest. So here we can, so it didn't like that. That is because we want this. So if we don't have 3 and we don't have 4, yeah. Interesting. I think we need to do something like that. It's a bit gross. Yeah. Cool. So now we're like doing a bunch. So what I might do is get rid of this, and we'll see how long it takes to do various things. So if we did like 10 requests, we can't connect right, can we connect to it there? Interesting. So here we're having an issue where we can't connect after one thing. So I guess after every loop, after doing this, we probably want to go to close sock FD, and then sock FD equal to -1, something like that. Mate. I think it's we need to kind of keep this round. Is that the case? Yeah, so that is the case. We do need to keep that object round. Are we making with like old ASAN and whatnot? Yeah, so we do have ASAN enabled here. That said it was like in a static place though, so yeah. Fair enough. So, what do we do from here? What I want to do is, I don't know, see if I kind of want to. Well, maybe I can do a grep for. I'll just pull that out. So I want to do a grep for basically the date. We can do a grep for 2025, which is the current year, and we can do a line count, and then that is 10. Cool. Maybe here we can do a num, and num defaults to 1, which was kind of what we want. But what if we say num is 10, maybe 10,000? Boom. How long does this take? Yeah, quite a while. 2 seconds. Should we get like a little average and like maybe note this down? So this is probably the most naive way you could do to get through X amount of connections, which is basically, so we look up the port, we kind of pre-do some work, but then each time we do it iteratively. We connect to one, we do the thing, we connect to another, we do the thing, we connect to another, we do the thing. So you only actually have one active connection at a time, which I think we could potentially have multiple active connections at a time. So perhaps I might look at starting to do that. But what I might do is maybe run this a couple of times and say what it was under kind of load. So this maybe we can just add it in the get add client.c, and we can go get commit minus initial version of client. Very naive, just does one connection at a time, blocking on everything. 10k takes around 2 sec. So this is potentially around 20 seconds, I would, or 21, 25, somewhere around that kind of line. For 100,000, I would expect it to be reasonably linear. So we're going up by a multitude of 10, so yeah, around 21 seconds. Easy. 100k, around 20 sec. Cool. And so now what we can do is try and make this hella quick. What we can do is we can use, perhaps we can use the most basic syscall that will stop with a lot of the like blocking on things. So what I'm seeing here is connect. It will block until you've actually made that connection. And as I showed on the Wireshark earlier in the videos, you send to connect, you send a SYN. You don't know whether you've connected until they send a SYN ACK and then you send another ACK. And so there's actually 3 packets here that need to happen. And so if you block on it, it kind of means that you just kind of have to stick around with it, wait until it finishes. And then read, it'll wait until the server is ready to send data. In my case, it is the case that as soon as you connect, it'll try and send data. But it's not actually as soon as you connect. It has to do a tiny bit of work before it is ready to send. And because of that, you're now having to wait until the server sends a push TCP packet, at which point you can then read, and then you'll read as much as you want. Cool. And then this write, it's writing to standard out. It could block. It potentially might not, but it potentially does. This printf, that will block. This flush, that blocks. All of it. All blocks. So what I kind of want to do is make this non-blocking. So, well, there's like a couple of things that we can do, and perhaps I could start with one that it's more, I don't know. So we can do something like this, and like for size T ID 0 and ID is less than I kind of maybe want to call it F. We'll see why in a sec. I kind of want to call it fork ID because we are going to fork in stuff. What was I doing there? Fork is, I was just doing that. And then fork ID plus plus. So here we want to do a PIDT F equals fork. So if, well, this is actually a child. So if we have some values, so fork is going to do a few things. So we're basically trying to do multitasking now. See if that helps it. So fork process of the child is returned to the parent, and 0 is returned to the child, and -1 on the error. So I think if child is less, well, E equals negative. I'm not used to this keyboard, I think if this happens, I want to do a P error on that fork, and then perhaps return defer that exit a failure. Perfection. So here I kind of want to do if child E equal to 0. Well, I kind of want to do, if child is not equal to 0, just continue. And then I kind of want to do yeah, I might do it that way. So we have a fork ID, and we're going to times it by fork count, and then we're going to add on that little I, which we get from there. Perfect. So at this point here, we've basically done a lot of forking. It kind of means that that kind of works. The return defer will kind of break out of whatever thing it does. So that kind of all added up to there. And now you kind of need to wait. So what do we need to wait on? I kind of want all of them to finish. So this is like until 1. But what I can do is just call wait 10 times, I believe. Yeah, I think. Oh, do we need to like? I feel like sig child is like a thing that can happen as well. But anyway, we can do something like fork that one, thanks. I plus plus, not that plus plus, but that was not too bad. And then we can just do something like this. I don't know. Where do you come from? This way. Weights, and I kind of want to sort those. Cool. So now it might take a bit less. Now it's like, because it's yeah, now it's like a little trickier, because theoretically they can print at like multiple times. So if we go back to something like this, it's printing out. I'm surprised it tried to do 10 at the end. Yeah, like that seems more than a lot more than necessary. That is because at the end of this for loop, we actually want a break. So we actually only want the fork to do it. Oh no, here we can actually just go. Something like this, but do success instead. So when we get to the end, but we'll still do any free up things if we need to. That seems a bit more right. But that doesn't seem as right, because I don't know. There's 10 of them. Yeah, I don't know. Like if I did 100 of them, we're kind of getting the right things. But you can see like some are like split over multiple lines. There may even be one with two dates on the same line. It doesn't really seem like it. I mean, we do the flush, so it's kind of interesting. Anyway, so if we did that num thing again, so this was, we'll start with the 10k. So that's a lot quicker. So if we look at what we were doing, it was 10 seconds, and now it's like less than 1 second. So if we did 100k, this should theoretically be like 7 seconds, I guess. 8 seconds, around that. So you can see just by forking 10 times can make a difference. Now, ls proc, in proc, yeah, in proc. I do actually have 16 cores on this thing, so perhaps that split wouldn't work for everyone. I also wonder, like if we did all 15, make use of that fully. This also won't divide evenly. Yeah, so we're missing like a chunk. So I think if I kind of want to do that, but it seems like extra kind of work in a hot path. Basically, if we're if the fork ID is the first one, then we'll do a bit extra to make up for any. And so now I would expect that number to be a bit more like that. In around 7 seconds. Yeah, cool. So now we're, I don't know, around 7 seconds for 100k. If we did 1,000,000, so this is making 1,000,000 connections back to back, it will be around 70 seconds. So it's still like reasonably slow. Like the time for one initial connection is pretty quick, but we're still only running like, well, 16 connections at once, and theoretically we can go wild. How wild do you reckon we can go? So this was like around a minute, so I need to just chat for a minute. So the next thing I might do is move to non-blocking sockets. So with non-blocking sockets, it basically means that the kernel, like the operating system, will tell us when there is stuff ready to read or write on file descriptors. And I need to keep an eye on the disk space. Recording a giant video. Oh, what am I thinking? Right, so that's just a bit over a minute. That's about expected. So that was just a really simple change, which just does the right thing. I kind of want to go here and like do that sort of thing. If we didn't do this wait, it would actually like it would just exit straight away, but it would still be print in the background. It can be kind of weird, like it's basically forked in the background. The same as if you put a curly brace in the shell. Alright, so this one was a not so significant change. It does have some timing issues with when we're writing to standard out and when we're not. So perhaps we need to have some kind of a lock on standard out so it is good, I guess, which kind of puts an overhead because then we're potentially always locking on that lock. Only one person can write at a time, but I think perhaps we should do it. Now there's a couple ways we could do it. Like all we really need is like an atomic. I think like atomic types. Yeah, there are like there are atomics. I don't know. Atomic. I haven't really done the atomics in C. I've done more of the like low level stuff, but because what we want to do is basically have. I like how it said you can assume into the atomic. Yeah, I feel like we don't actually need to worry about that. What we kind of need to have is like we need to have an int, but it needs to be in like some space that is readable and writable from all children. So what we can do is a syscall map. So what we can do is we can basically pass in a null for the address. The length is how much we want to do. We can just have the size of whatever, and then we can yeah, we can do this. I mean, what I really want to do is, what do you call it? Is it like a semaphore? There are like POSIX ones. That's gross code. Yeah, so there are like POSIX semaphores, which is kind of good. So we have to have pthread, which yay for all these ads. Like, what if you don't have so in SemWait, do you need a you don't need the pthread. You do need the pthread library. See, that I don't like as much. I mean, this is, I don't know. I love that. That's what a semaphore is. It's just a traffic light. Yeah, like, what's this thing? Keep that in there. Like, go away. Like, I wish, like, the internet would go back to how it was. Threads use less resources. Interesting if that would actually be beneficial to us. Helpful. So I wonder, fork Linux protect critical path. Is semaphore the thing I want? Semaphore. Currency. Not sure semaphore is the thing I want. What are the operations? See. Yeah, so semaphore with just two things. This is a new text. Alright, so what I really want is just this. Yeah, so like this needs some atomic. Yeah, like shit can run there. Um, don't really say what it is. Um, ugh, I think I need to think about this a bit more. Basically, I want something here that I can do something like this. And then do all of that. And then something like that. And like potentially even like, yeah, I don't know. Anyhow, like this is kind of showing how, well, like, I don't know, we kind of do need to make sure this is legit. Because the problem is, during every single one of these lines, there's like 15 other programs running the same stuff, including that. I think I might leave it for now, and just keep it as the one that kind of goes a bit haphazard and like that. That was a big number. Yeah, like it kind of works. I don't really want to use the sim stuff. And I think there's like more things. There's p threads. That's what it is. Yeah, because like I'm not using threads, though I could change the thing I am using to use threads. But I don't know. I guess I'm. Cool. These docs are like. I don't know, because they have like cons and mutexes. The mutex is like kind of the useful thing there. Oh, there's Vutex, I remember this. So Vutex is fast user space locking. Right, so we have to do a syscall. Cool. Futex might be the thing that I want to do. You do have a little, so we have a little thing, so we need to have a bunch of things, so editor, are you just a static thing? You are, right, so you're just a static even32. Right, so we do something like this. We have some address to store stuff. There's our futexes. We initialize them, I guess, and they're just ints. And this f wait and f post, I guess, is our kind of locking. So that's just wrapping it. Cool. STD atomic, I think that's why I kind of won all along. Just doesn't really say. Example things. Cool. Yeah, so what are we doing? Program source. This is that. So we do that, and we're waiting. I don't know where this. Oh, yeah, it's in there. Cool. And I mean, really, that's. Yeah, so that's if we got it. Otherwise, we wait. Let's give this a whirl. Cool. So in we needed so we wanted std atomic.h, cool, and we also wanted linux /futex.h. I mean, this is now into Linux only specifically. But like, do I need it? I don't know. I feel like, I don't know. Maybe I'll just leave it as is, and it does something a little funky, but we can work out what 10,000 was. It was like pretty quick. What is? I use it so infrequently that I don't actually know the things. Cool. So, do we want that? Yeah, sure, why not? Do we want that? Sure, why not? Do we want that? Sure, that's just done. Get commit. So this next version forking 16. Was it 16? Fork count 15. Times has concurrency issues for printing to the out. Cool. Now 10,000 was quick. 10k and 0. 7 sec. Okay, in like 8 sec, 7 sec. And the 1 mil is like a minute 10. Something like that. And yeah, potentially should fix the concurrency issues. I don't think that, well, it potentially would. Like if you're having to wait continuously to be able to print, but then like things shouldn't be printing all the time, so there should be gaps in that the computer will just friendly do for you. Cool. That's that. It's still running. Right, yeah, it was about what I expected. Cool, that's that. Cool. So what I might do is just leave that as is there, and I might try and fix the fix up the other thing, concurrency printing. But yeah, I think that is all for now. I'll probably come back to this because, as I mentioned, I've already done this project kind of on the other side, but I kind of wanted to step through each of the progressions to kind of show what's useful and what, and like kind of the complexity required for some of them. Like when we get to non-blocking, it gets like a little more complex. But I mean, it is what it is. It also gets hella quicker. Ooh, looking forward to it. Anyhow, the server that it's currently going off is using some of those event-based stuff, but there's still limits that I can fine tune on that. But when we get to the server side of this little project, we'll be able to see that. But anyhow, that's me for now. Hope you enjoyed watching this, and feel free to check out some other videos. I'll probably be updating this a bit more now that it feels a bit more bearable being in this office, which is nice. It was a cold winter. Anyhow, see ya.